Hey guys, today we're going to continue with angles, and we're going to talk about two main types of different pairs of angles, and then we'll have a lot of time to kind of practice and make sure we have everything down and feeling good with. Alright, so our first types of angles, first special pair that we have, we call them adjacent angles. And adjacent angles, this is on the first slide if you're following along with that slide presentation. Adjacent angles, this is going to be a pair of angles, and our definition says it's two angles that have a common vertex and a common side. So what that means, and we'll go in black here, that means, let's say we're going to make two angles here that look like this. Say A, B, point C, and point D. To be adjacent angles, you need to share a vertex and share a common side. In order to tell this, you really need to have your parts of angles down, but I'm going to give us two adjacent angles here. Angles CAB and angle DAC. These two angles are adjacent, and I'm going to explain why. So angle CAB and angle DAC are a pair of adjacent angles. They are adjacent to one another. So these two angles are adjacent. Now the definition says to be adjacent you need to have a common vertex, and notice they both have the vertex of A. If you look at them, A is their vertex for both, so common vertex, and the vertex is point A, so common vertex A. And here they share a side, so angle CAB has two sides. The sides are AB and AC. Angle DAC, the two sides are going to be this ray AD and the ray AC. So by looking at those two, you can see that they both share the ray AC. So the shared or the common side is the ray AC. So for two angles to be adjacent, they need both of these things to be true. They need to have that common vertex right here, and the common side, which is AC. Some people think of them like neighboring angles. They border one another. That side is what they have in common, along with the vertex. So, I'll draw a couple more examples of adjacent angles. Let's say we have, okay, we'll do this. We'll go right here. And then we're going to go, we'll make a line that goes through. And we'll do a few in this one. This is point A down here, point B, point C, point D, E, F, and point G. So let's start with, we'll go with angle DCA. So angle DCA, that would be this angle here. To be adjacent to DCA, I'm going to name two angles here that are adjacent. One of them would be BCA, right over here. So angle BCA. And this is adjacent because they share the vertex C, and these two angles share our ray with the side CA. So BCA is adjacent to DC. So these are a pair of adjacent angles. And there's also another pair. So our original angle is angle DCA. And let's say we're not looking at this angle anymore. Another adjacent angle to DCA here we'll see is angle DCE. Ooh, DCE. Vertex should always be in the middle when naming. And these are adjacent. They have the common vertex of C, and they share the ray CD. So these are adjacent as well. And we'll find one more pair here. Let's do, we'll erase these. Let's do angle FEC. So angle FEC, let's get rid of these guys down here. Angle FEC, this angle here, to be adjacent to angle FEC, you need to share a vertex and a common side. So our sides for FEC, well, we have the ray EC and we have the ray EF. So we need to find an angle that shares one of those sides and has a vertex of E. And you can see over here, this angle is made up of the sides EG, that ray, and the ray EF. So this angle will be adjacent. Angle G, EF, they are adjacent. Again, you have to share the common vertex and a common side. So don't meet one of those two criteria, you need to meet both of those to be adjacent. Alright, our next vocabulary word, still on that first slide, is called vertical angles. So vertical angles, our definition says, these are opposite angles that share a vertex. So vertical angles are opposite angles that share a vertex, and they are generally formed by the intersection of two lines. Could be like two rays that intersect or two segments, but they need to intersect in a way like this. So we'll use two lines where we form four angles here. And we'll use our normal notation here. Call it A, B, C, D, and E. Fix our C. So vertical angles, the definition again says opposite angles that share a vertex. And they're going to be formed by two intersecting lines. Let's just choose a random angle, and I'll choose this angle right down here. That's going to be angle ECB. Now angle ECB, that is going to need, in order to be vertical with that, we're going to have to find an angle that shares a vertex and is opposite of this. So ECB, well, we have three other angles here that we're going to look at. And one of, or actually all three of them share a vertex, but the only one that's opposite would be angle DCA. This angle that's on the opposite side right up here. So angle DCA, this is a pair of vertical angles. This is a pair of vertical angles. And there you go. Share a vertex and they're opposite of one another. Formed by two intersecting lines. Needs to be two intersecting lines. And we also have another pair of vertical angles. So I'll go in green here. Let's say we have angle DCE, angle DCE. To be vertical with this angle, you share a vertex and you're opposite. Again, this is because we have the intersecting lines, these angles exist. So that means angle ACB would be a pair of vertical angles. So DCE and ACB are a pair of vertical angles. They share a vertex and they're opposite. They're formed by two intersecting lines. So let's see if we can start to find these angles and name them in different diagrams. So we're going to go on to slide 2 now. And slide 2 is going to tie some of the stuff we did yesterday in as well, because we want to constantly be practicing and making sure we don't just remember it when it's taught, but remember after it's taught as well. So in slide 2 we have this diagram. Looks like this. And we go right about here. We have this marking. And we have some points. All these points are given to us. H, J, A, L, K, M, and D. And for these, we're going to start with number 1. Number 1, we're given angle JKL, and we are told we need to first classify this angle. We need to secondly name 2 angles that are adjacent, and then name all the angles that are vertical. So let's classify first. JKL, we're talking about this angle here. We're going to classify it, and by looking at it, I'm sure we can see that it is a obtuse angle. It's greater than 90 degrees, but it's less than the 180. So we would classify this as an obtuse angle. Now to be adjacent, that's our second step. Do it in pink. To be adjacent, you need to share a vertex and a common side. Well, the 2 sides of JKL are KJ, that ray, and KL. So let's say we share the side KL. Share in the side KL and the vertex K, we have this angle here would be a good adjacent angle. So angle DKL is adjacent to our original angle, JKL. And let's say we go and try to find another angle that is adjacent. Go into our original here. Let's get rid of DKL. Let's say we focus on the other side of angle JKL, and that would be ray KJ. If we share that side and we have a common vertex, that would make angle JKM. And that would be adjacent to angle JKL. So there's 2 adjacent angles, and now we just need to name a vertical angle. So JKL, to be vertical, we just need to be opposite and share a vertex. So right down here, we're opposite, we share a vertex. That would be angle DKM is vertical to angle JKL. Alright, so that was number 1. Go ahead and try number 2 on your own. You feel free to pause the video, and then you can check and see if you get the same answer. I'll complete number 2 right now. See if you really have it down. Erase this, and we'll get rid of that. This was point K. Alright, number 2 says we're looking at angle LKD, number 2. Angle LKD, angle LKD, right here. And our first step is to classify. So looking at this angle, we should see that it is acute. It is less than 90 degrees. And our second step is to name 2 adjacent angles. So again, to be adjacent, you need to share a vertex and a side. The 2 sides of LKD would be KD, we have that ray, and the ray KL. Those are the 2 sides of this angle. So if we want to name an adjacent, let's say we focus on the ray KD. If we share that ray, then we are going to be this angle down here. So angle DKM is adjacent to angle LKD. Those are a pair of adjacent angles. And let's say we don't want to use that angle. We can also use the other side. We can also be, or share, have a common side with the other side of LKD. That would be side KL. So let's say we're right over here, and that would be angle JKL is adjacent to our original angle LKD. So those are 2 pairs. We were only asked to find 2. There are some other ones that we could find, but we're going to focus on the very basics for now to make sure we have them down, and then when we feel comfortable, then we'll start to explore into some other relationships here. But there we go. There's our 2 adjacents. And now we just need to find a vertical angle. So a vertical angle, you need to share a vertex. You need to be opposite. Notice we have the 2 lines intersecting. It's going to have a vertical angle. So you share a vertex, you're opposite, angle JKM is vertical to our original angle, angle LKD. Okay, so that is number 2. Now number 3, our last one here before we move on to our final example. Number 3, we're dealing with angle KJA, and angle KJA we can find on our diagram here. KJA, so let's see. KJA would be this angle right here. Now if we are classifying this angle, that's our first step, we should notice that it's a right angle. It has a measure of 90 degrees. That's what this marking right here does. That little box tells us it's 90 degrees. And I'm going to change colors again. So let's go to our second part. Name 2 adjacent angles to KJA. So there's 2 sides, and we have JK is one side, JA is the other. So we need to share a vertex and have a common side. So we'll have angle, not J, angle HJA, this angle right here, is also, or is going to be adjacent to our original angle, angle KJA. And I'm actually going to leave it at just that one for now, because if we look, the other side, we could use this whole straight angle here and say that is adjacent. And we'll talk more about like those relationships on a different day. But one thing I do want to point out is, in reference to KJA, this angle, this right angle, some people make the mistake of thinking angle LKJ is adjacent. They think this angle is because they see that common side. But unfortunately it's not adjacent because they don't share the common vertex. So don't fall for that. You have to have that common vertex and the common side. All right, and our last part would be naming any vertical angles. Well, notice for angle KJA, there's no angle that's opposite because we don't have 2 lines intersecting here. We have a line and we have a ray that's endpoint falls on the line and is extending out. So there's no intersection where you could have that vertical angle. So there are no vertical angles here. Okay, that was slide number 2. We're just going to move on to slide 3, and then you can go ahead and practice on your own a little bit. So slide 3, we have 4 questions, and we're given this diagram. I'll do my best to draw. Here we go, and we look like this. And we're given points. So our points, we have point E, point F, point A, point B, and then we have G, C, and D. Alright, so I'll do the first 2 with you. I'll let you try 3 and 4 on your own. I'll post those answers on here though, so you can see if you got them right. Alright, so number 1, it says which angles are adjacent. So we want to be adjacent to angle EGD. Angle EGD. So EGD. Which angle is adjacent to this angle? And we're given 4 angles to choose from. So you can see that right in the slides. Our 4 angles that we had to choose from were AGF, angle CGD, angle AGB, and angle BGC. Which one of these 4 is adjacent to EGC? So EGD. Here we go. And let's look. AGF. Well, AGF shares a vertex, but it doesn't share a common side. It doesn't have either EG or GD. So this one does not work. Angle CGD, CGD, well, shares a common vertex. It also shares the common side of GD, so this one is adjacent. They have a common vertex and a common side. That's what it means to be adjacent. Let's check the others just to make sure. Angle AGB, AGB, that would be this angle right here. You can see that they have a common vertex, but they do not share a common side. Actually, these two angles would be vertical to one another, but they're not adjacent. Our last one was angle BGC. That would be this angle right down here, and they share a common vertex but no common side. So your answer for number 1 was angle CGD. All right, number 2. We are asked to list which angle is vertical to angle, and we're on BGA. So vertical with angle BGA. So BGA is right here, and we need to find the angle that's vertical with BGA. Our options are AGF, angle CGD, angle CGE, or I'll write it down here, angle DGE. Those are our options. So AGF, AGF, AGF is not vertical. It shares a common vertex, but it's not opposite. It actually is adjacent. They share a common side. Unfortunately, though, not vertical. Angle CGD, now they share a common vertex, but if you look at the two lines that are forming this angle here, it's this line, this AD, that line, and the line BE. So to be opposite, you need to be opposite on those lines. So this really isn't opposite because it's not using the same two lines. It's using CF and AD. So this one shares a vertex, but it's not opposite. That one can be a little tricky. You need to use the same two lines when you're looking for vertical angles. And this diagram has 3 different intersecting lines. We have angle CGE, CGE. So again, we have the same vertex, but we're not using the same lines again. We're using CG or CF, this line here, and the line BE to form this whole angle. And we were using the other two lines, or these two lines, to form our original angle, so that doesn't work. Hopefully this last one does. We have angle E, or DGE, that's this angle here, and if you look, same vertex, and they are opposite using the same two lines. Here's your winner. That's the angle that's vertical to angle BGA. Alright, so go ahead and try 3 and 4 on your own. You can pause the video if you'd like, give it a shot. Number 3, I'll just write your answers here. You're looking for the angle that's vertical to angle BGC. Get these out of here. BGC. So the angle that's vertical to BGC, out of your options, well, your answer should be EGF. I think they list it as FGE though. FGE, that would be your vertical angle. So this would be your winner. And our last one would be number 4. And number 4, you were looking for the angle that is adjacent to angle AGF. AGF. So you're looking to be adjacent to AGF. And with the options that you were given, you can rule out the first one, DGE. You can rule out the second one, AGC. That would be your winner here. AGC. That would be adjacent to AGF. They share the vertex G and they share the ray GA. So that would be your winner. The last one would not work. CGD. That would actually be a vertical angle with AGF. Okay. That's all for the day. You can go ahead and practice on your own a little bit. I'm going to spiral in some of the other things we've done with angles just to make sure that we're really holding on to the information, because it accumulates a lot in geometry. You got to keep holding on to the info. Alright guys, have a nice day.